Mindsetters, welcome to Learn Extra Live. I'm Katleho and this is Natasha. How are you, Natasha?
Hi, I'm well, thanks Katleho. Nice to see you
Nice
again.
to see you too. I've been here for many Mondays now,
You
so
have.
we've been enjoying it. So as we know, we have finally reached the grade 12 show. And today, paper 1, and finally, for all you who have been wanting it, it's paper 3 as well, hey?
Yes, and grade 12s, obviously you're busy with revision now in the middle of prelims and all of that, so we're doing some nice exam revision for you this evening.
Okay, so thank you, Natasha. You can go over to your board. So guys, as you know, because it's Monday, we have some prizes. We have the Casio calculator as well as the Casio labeler. And as always, I don't even need to say this to you guys, but these prizes do go out to the most amazing, most fantastic, most excited, most everything mindset on the page. As you know, we have been posting up the winners for the past many weeks. So you know that it is very possible and very easy to win. You just have to want to, and you have to be involved. Our Facebook page is facebook.com/learnextra, and our Twitter handle is @learnextra. Thank you again to Liberty. Liberty has been absolutely awesome today, and I know your focus is going to be so high today because with prelims, with exams, with finals even, this show is imperative to you for passing. Over to you.
Thanks Katleho. All right guys, so this is it. It's exam time. Well, it's an exam revision on the show, and we're going to look at paper 1 and paper 3. Firstly, we're going to start with a question from paper 1, a past exam, and most of you will know if you've been practicing exams, which you should be doing by now, that calculus is one of the biggest sections in paper 1. So we're going to look at a calculus question today, but specifically one that I know a lot of students seem to battle with, and that's the derivative graph. All right, so the first question we're going to look at is calculus derivative graphs, and then later on we will look in paper 3, we will look at a question on geometry, and if we have time, do a little bit more calculus, because as I said, one of the most important sections that you guys will be doing. All right, so let's get to it. So this question comes from the November 2010 paper, and hopefully you guys can read that. I will read it out to you, and I will try and get the graph and all of that in focus as we go on. Okay, so it says that the graphs of y is equal to g dash x. G dash x being the derivative graph, guys. So they tell you the derivative graph is ax squared plus bx plus c. Now, if you think about that for a second, if your derivative is giving you a quadratic function, then that means the original graph had to have been cubic. Because remember, if you take something to the power of 3 and you derive it, you're going to end up with an x squared. So therefore, the derivative graph is a parabola, as I will show you just now. So that means the original graph, g of x, must have been a cubic graph. All right. They also tell you that h of x is equal to 2x minus 4, so that's just a straight line, and they sketch both of these for you. And they tell you that the graph of g dash x, the derivative graph, is the derivative of a cubic function, but we'd already known that. Okay, they give you a few points. They tell you that they have a common y-intercept at the point E. C is the point minus 2 and 0, so that's one of the x-intercepts. D is 6 and 0, that's another x-intercept. And A is the x-intercept of H, which is your straight line. B is the turning point of G dash, and they tell you that AB is parallel to the y-axis. Okay, so this is basically what's happening. This is a graphical representation of everything that they have told you thus far. Okay, so let's have a look. E is your common y-intercept. You can see that. You've got B as the turning point of your parabola. D is the point 6 0, C is the point minus 2 0, and H is your straight line. Okay, so let's have a look at the first question. And this question, remember, is from the November 2010 paper. Okay, the first question for 1 mark, write down the coordinates of E. So guys, if you look at the graph, right, E is the y-intercept of both the parabola and the straight line. Now remember, how do you find y-intercepts? All you have to do is say let x be equal to naught. This one is actually nice and easy for you to do because they've given you the equation of the straight line. So they've told you that h of x is equal to 2x minus 4. So we can quite easily find the y-intercept from that graph. So h of x is equal to 2x minus 4. And remember that the y-intercept of the straight line and of the parabola are both the same. So therefore point E, okay, so this is question 1, and I'm looking at point E, which is the y-intercept. How do I find y-intercepts? You say let x equal naught. So in h of x, I'm going to say h of naught. I'll get 2 times naught minus 4, and that will give me an answer of minus 4. So therefore, the coordinates of point E are, it's your y-intercept, remember, so the x value is naught, and your y value is minus 4. Okay, so the first question, nice and easy, just working out the y-intercept of the straight line, which is obviously going to then be the y-intercept of the parabola. Okay, the next question for 4 marks. Determine the equation of the derivative graph in that form y is equal to ax squared plus bx plus c. So guys, they want to now find out what the equation of this parabola is. Remember, this parabola is just the derivative of the cubic graph. And so this parabola itself will have its own defining equation. And they've given us a whole lot of information that will help us to find this defining equation of your derivative graph. Okay, so this is number 2. And we are working out the equation of g prime. Okay, so in the form ax squared plus bx plus c, and hopefully you all recognize that equation of a parabola. There's lots of different ways we could work it out. I'm going to use the one that you learned right in the beginning when you first learned how to work out equations of parabolas. We've got both the x-intercepts and we've got a point on the graph. Remember, we've just worked out that E is the point 0 and minus 4. So if I want to work out the defining equation of the parabola, I can use this formula. Y is equal to A times x minus x1 times x minus x2. All right, guys, and remember the x1 and the x2 here, those are your x-intercepts. When you find the equation of the parabola, you need to have your x-intercepts if you're going to use this formula. You'll also need another point on the graph, which we have. So we've got x-intercepts and another point on the graph, therefore we can use that formula. All right, so we've got y is equal to A. And remember, we don't know what A is, so the point of using this formula is to help us find out what the value of A is. Once we have the value of A, we'll be able to find the equation. So y is equal to A times x minus x1. Very important to use brackets here so you don't confuse your signs. x1 being the first x-intercept, which was minus 2. All right, and then your second x-intercept was 6. Okay, so it's x minus minus 2 and then x minus 6. The point that we have that we can use to substitute, the other point that lies on the graph, is 0 and minus 4. Okay, so I can substitute x is 0, y is minus 4 into this equation and work out the value of A, because now A would be the only unknown. So therefore I get A times 0, minus times minus is a plus, so this would just be plus 2, and then 0 minus 6. Okay, so I'm going to get minus 4 is equal to A. 2 times minus 6 is going to give me minus 12. All right, and then dividing both sides by minus 12, I will get that a is equal to a third. All right, so guys, we use that equation, y is equal to a times x minus x1 times x minus x2, to help us find the coefficient of x squared, to help us find the value of a. Once we've got a, we are not done, because remember they wanted the equation of g dash x. They wanted the equation of this derivative graph. So we're not just going to stop by giving them the answer for a. We now need to take that value for a and put it back into this line here so that we can times it out and get the equation. So we'll get y is equal to a third times x plus 2. And then we've got x minus 6. Okay, and let's just multiply that out. Okay, there we go. And I'm going to need a pen. There we go. So we get a third into x squared, and all I'm doing is just multiplying that bracket out. Plus 2x minus 6x is going to give me minus 4x. And then plus 2 times minus 6 will give me minus 12. Times your 1 over 3 into that bracket, and you're going to get a third x squared minus 4 over 3 x and minus 4. Okay, and in fact, when you get this y-intercept, it's actually a nice quick check for you, because remember the y-intercepts of both the graphs are the same. So if c is minus 4 in the parabola, and we know from the straight line we worked out that the point E was 0 and minus 4, so the y-intercept of the parabola being 0 and minus 4 matches up with the straight line, so we know that we haven't made any mistakes there. All right. Okay, so we're going to go on to the next one, which is writing down the coordinates of the turning points of G. Now here you've got to be careful, because remember we are dealing with the graph of the derivative. We've got G prime x, G dash x, okay? But now they're asking you for the turning points of the original graph. Now your original graph was a cubic function. So your original graph had the equation y is equal to a x cubed plus b x squared plus cx plus d. Remember, that's your defining equation of any cubic graph. Now, because we can already see that the gradient of this, or the derivative of that cubic graph, is positive, because look, we've ended up with a happy smiley parabola, which means the gradient is positive of the cubic function, your original graph would have looked something like this. All right, that would have been the shape. Okay, now guys, if you think about it, because remember, when you're trying to find the turning points of this cubic graph, what do? How do you find turning points? Okay, remember, when you find turning points, you have to find the derivative and you make it equal to 0. So if I had the equation, if I knew what A, B, and C, and D was, and I asked you guys to find the turning points, then you would say, okay, well, to find the turning points, we say it's where the derivative is equal to 0. Okay, because when the graph is turning at that point, the gradient is 0. Okay, so if I wanted to find the turning points, I would say let the derivative equal to 0. But now we actually have the graph of the derivative. So where that graph is equal to 0, that's actually going to be the turning point of the original graph, y is equal to ax cubed plus bx squared plus cx plus d. Okay, so let's just show you this on our graph here. This graph of the derivative, okay, so this graph of g dash, we see that it is 0 at the point C, 0 meaning that the y value has to be 0, okay? It's 0 at the point C and at the point D. So in other words, the derivative is equal to 0 at x is equal to minus 2 or at x is equal to 6. Okay, so the derivative, because remember this is the graph of the derivative. So we're looking for where the derivative of the original graph is equal to 0, because where the derivative is 0, that gives us our turning points. So therefore, the derivative is equal to 0 at the x-intercepts. So that means that the original graph will have turning points at x is equal to -2 or at x is equal to 6. And that's the answer for that one. Write the x-coordinates of the turning points of G. And the answer there is going to be x is equal to -2 and x is equal to 6. And this is an important concept, so I hope you guys understand that. All right. Okay, we've got a few more parts to this question. I don't know if we want to just carry on with it.
Let's just take a break, and then when we come back, we can go through the question.
All right.
So guys, we're going to take a quick ad break. When we come back, make sure that you are 100% focused, because this is such an important thing to do in your revision. See you right now.